All right, everyone. Good morning, good morning. It's another gorgeous morning outside. I just want to give you a few announcements this morning. On your way out, I have brought back your problem set number 1 and problem set number 2 if you haven't picked those up. It's kind of nice to have those worksheets already graded so that you can study for them. Remember, the exam is next Wednesday. I'll give you some instructions as we get closer. I'm going to try something new this semester. We're going to try Proctorio for the exam 1. So what you'll need to do is bring a computer. Yes? Sure. I'm going to post an answer sheet so you can kind of compare. I'll do that today, and I'll put that in the same link as the assignment. Okay? Yeah, absolutely. I am recording this lecture as well, so I just need to post last Monday's lecture. I did capture that as well, and today's lecture. Also, let's see. Okay, so Proctorio, I need you all to bring your computers. If your computer isn't working, say that morning, I will bring some extra hard copies. This is a new technique, I guess. This is a new technology for me. So I'll have some backup for you guys too, okay? Any questions so far? And again, today I'll announce the formal review session sometime on Monday, okay? Monday afternoon. All right, so let's go ahead and get started. Today we're starting with the nervous system and neurons. We'll kind of take an overview of the brain and spinal cord today, so it'll be more of an overview of the nervous system. You do have a recorded lecture already online, but I have some extra videos and interesting facts today too that aren't on the video. I will post the instructor copy today as well. All right, so let's get started. Why don't you get your top hat devices out? I do have a couple of top hat questions today. All right, let's start with this one. This is a review from last time. These types of junctions are specialized protein complexes that create an aqueous pore between two adjacent cells. Are those A, tight junctions, B, desmosomes, C, gap junctions, or D, all of the above? So this was in the section epithelial cells, the module where we talked about epithelial cells on Monday. Remember, your homework assignment also is due on Friday regarding cystic fibrosis. All right, we already have about 70 students who have answered. Let's see if we can get up to 90 here. All right, I'll give you about 5 more seconds. We're up to 90. Anybody in this room need some more time? All right. Okay. Oh, you need some more time. Okay, I'll give you 10 more seconds here. We will have another set of questions, a couple more questions. Just give me the thumbs up when you're ready. Not yet? Okay. Oh, okay, no worries. I know you're here, so just come up to me after class, too, if you're having some connection issues. All right, so I'm going to go ahead and close this one. The correct response is C. All right, good job. Let's see here. So we have about 77% of you guys got that right. Let's go to the next one. When a molecule moves across an epithelial structure in between two cells, scientists refer to this movement as A, transcellular movement, the movement of this molecule as along the A, transcellular pathway, B, paracellular pathway, C, apical pathway, or D, none of the above. All right, we're up to about 88, 90. I'll give you about 5 more seconds now. Got about 95 people that answered last time. Sweet. Okay, so this is probably a good chance that I will be using this one for your top hat quiz grade. 98 people. Anybody need some more time in this room? All right, so I'll go ahead and close this one. The correct answer is B. Okay, so transcellular pathway, this means that these molecules are moving through the cells. They're going across the apical or basolateral membrane by a channel or a transporter, and then crossing the opposite membrane. If it was the apical, then the opposite membrane is the basolateral membrane. So in other words, the transcellular pathway is moving molecules through the cell. Paracellular pathway means that molecules are moving in between two cells across that tight junction. And then C, apical pathway, yeah, that's moving across one of the membranes, but it really wasn't something we talked about in the epithelial cell module. All right, so again, the correct answer is B, paracellular pathway. One more. All right, what pathway is activated by UTP? I think we're gonna skip that one. That was actually the GQ coupled pathway, if you remember. But I told you didn't need to memorize and I don't have the actual diagram. So UTP is a ligand that activates a receptor, purinergic receptors, that activate GQ coupled pathways. All right, so let's get started with neurons, the nervous system and neurons. Some interesting, spice it up a little bit. I always like the historical perspective too. Today we're going to be talking about a conflict on how to think about the nervous system between Golgi and Cajal. All right, so the nervous system, let's go back here. The nervous system is actually made up of, there we go, 2 major divisions. The central nervous system, which is composed of the brain and the spinal cord, and the peripheral nervous system, which is composed of nerves that connect the brain and spinal cord to all your other parts of the body, muscles, glands, and sense organs. The neurons are basically the cell type of both systems. So let's go through the central nervous system and peripheral nervous system. I'll elaborate a little bit more on the peripheral nervous system. Again, the CNS, central nervous system, is comprised of the brain and spinal cord. The peripheral nervous system has different types. One is the afferent division. I sometimes say afferent, just so you guys know the spelling. Afferent is basically sending signals to the central nervous system. And that's made up of the somatic sensory system. That includes senses that can sense pain, temperature, mechanical stimulation of your skin. So that's the somatic sensory system. The visceral sensory is actually giving you some information. It's sensing what some of the changes in organs, blood vessels, and glands. Visceral is telling you it's something about the inside of your body pertaining to organs. And then the special sensory, that includes hearing, tasting, the senses, seeing, sight, touch, and smell. Yes?
Can you repeat what somatic sensory is?
Yeah, so the somatic sensory includes receptors for pain, temperature, and mechanical stimulation. All right, so these are receiving input from the outside, the brain and spinal cord, and it's sending signals to the central nervous system. Efferent, which I sometimes say efferent, so you know that's an E in the spelling. Efferent division sends signal from the brain to parts outside the central nervous system. So basically it's sending signals away from the central nervous system. And that includes the somatic motor neurons. These motor neurons are controlling your muscle, right? When you think about lifting your arm, or say you're in the gym and you're lifting weights, your brain is telling you to pick up that weight, and it's moving, it's stimulating a moving muscle. Those are your somatic motor neurons. And then the autonomic system. These are your autonomic nervous system. It is comprised of the sympathetic nervous system. This is your typical fight or flight response. We'll get into more depth in the sympathetic nervous system in a bit after we talk about neurons. The parasympathetic, this is your resting and digesting. So just to give you an example, when you get scared, you'll notice there are certain physiological changes. You may get a little sweaty, your palms get sweaty, your face turns white, but mainly you notice that your heart starts to race. Okay? That's part of the fight or flight or sympathetic nervous system. The parasympathetic does the opposite. Parasympathetic is the resting and digesting, and that causes your heart to slow. So it actually has antagonistic effects. The enteric system, you may or may not have known this, but your GI tract is one of the most innervated organs in your entire body. Okay, so it gets a lot of input from neurons. Basically what's happening is you need all of that input to help with motility and digestion. All right. So there are different classes of neurons. We're going to talk about three of these, three classes of neurons. The afferent neurons, again, are receiving. They have sensory receptors that are receiving input and delivering that signal to the central nervous system. See the cell body. Now, one thing that is problematic with this particular figure is that it doesn't have any dendrites. So this is mislabeled. The afferent neurons do not have dendrites. All right, so then there are interneurons that receive that signal. There's some integration. And I just want to tell you that 99% of all your neurons in the body are interneurons. 99%. That's a lot of integration. So, that's an important fact. Efferent neurons receive signals from these interneurons and essentially send signals to structures outside the central nervous system, including muscle glands or other. We're going to be talking about muscle mainly in this class, so we're going to be talking about those motor neurons when we talk about how neurons work. So if you need some text associated with this is a nice table that's summarizing most of the things that I've talked about. But let's focus on neurons just for a minute, give you an overview of what they are. Neurons are nerve cells, and they are amitotic. That means that they don't divide. The implication of that is if you have any kind of spinal cord injury, a lot of times that is something that you can't overcome because nerve cells don't regenerate. And they do have a very high metabolic rate. which is interesting. Some people have hypothesized that diseases like Alzheimer's disease could be a type of diabetes, right? Because again, nerves actually require a lot of nutrients, energy, sugars, right? And so one proposed treatment is actually to use nasal sprays to try to get glucose into the brain, which is interesting, right? I'll post some papers on that, but that's one kind of idea with certain diseases like Alzheimer's disease. So clusters of cell bodies are in the central nervous systems. These are called nuclei. We're also going to be talking about clusters of neurons called ganglia. So I'll talk more about that when we get to the sympathetic and parasympathetic and compare and contrast those two types. And then neurons are not the most numerous cells in the central nervous system. It's actually glial cells, these supportive cells that help with neuron function. All right, so this is a very important concept as well. This is telling you that usually the signals are relayed from one neuron to the next. Some important terminology here is the signal that is delivered to one neuron is called the presynaptic neuron. Neurotransmitters are released. It signals the postsynaptic neuron, and then so on and so forth, right? So it is individual neurons that are signaling other neurons, specifically when we're talking about those interneurons in the central nervous system. So a single neuron postsynaptic to one cell can be a presynaptic to another cell. All right, so let me just introduce a scientist. This scientist is Santiago Ramon y Cajal. Very famous for his ideas, his drawings and his ideas about how the nervous system works, and specifically the fact that neurons, individual neurons, synapse with other neurons. Okay, so I'm going to just show you a movie here real quick. I think the occurrence that happened at the, so remember I talked about Einstein winning the Nobel Prize in 1906 for his ideas on diffusion? Well, this same year, Cajal and Golgi actually won the Nobel Prize for their ideas about the nervous system. Okay, so I'll talk more about that in just a second, but let's introduce Cajal.
Santiago Ramon y Cajal was born on May 1st, 1852 in Navarre, Spain. His father, a doctor and anatomy teacher, took young Santiago for walks through graveyards to find bones to sketch. His father was trying to inspire Ramon y Cajal, who hoped to be an artist, who was something of a hellraiser. By the age of 11, he had already been asked to leave several schools because of his rebellious attitude, and had been imprisoned for destroying a neighbor's garden with a homemade cannon. The graveyard excursions did the trick. Ramon y Cajal went to medical school at the University of Zaragoza, where his father was employed as an instructor. He successfully completed his studies and went into service in the Spanish army as a medical officer. Ramon y Cajal spent only a few years in the army before coming down with malaria and tuberculosis during an expedition to Cuba. Returning to Spain, Ramon y Cajal continued to follow in his father's footsteps. He pursued his doctorate in medicine in Madrid and became an anatomy professor at the University of Valencia, then the University of Barcelona, and finally at Madrid University. It was during his time in Barcelona that Ramon y Cajal learned of a new development in histology, the investigations into the microscopic structure of tissues. Camillo Golgi, a researcher at Pavia University in Italy, was doing histological studies on the nervous system. At this time, it was not clear what nervous tissue was made of. They could see it was composed of something fibrous, densely packed together, but it was impossible to tell how these fibers were arranged or what the fibers were doing. Some researchers, including Golgi, favored the reticular theory, the idea that the nervous fibers formed a dense, continuous net. Others, including Ramon y Cajal, supported the neuron theory proposed by Heinrich Waldheim. That is, nervous tissue must be made up of individual cells called neurons. Golgi developed a revolutionary stain made of a weak silver nitrate solution, which completely stained single fibers in the nervous tissue while leaving the surroundings unstained. Santiago Ramon y Cajal began investigating nervous tissue in earnest, making use of Golgi's stain. He would take small slices of brain tissue and then infuse them with the Golgi stain to reveal the underlying structure. He started in the cerebellum and then moved to the spinal cord, and then the cerebrum. Over the course of more than 25 years, he investigated most of the major parts of the brain in humans and many other animals. His talents as an artist were invaluable, as he documented his work with meticulous technical illustrations. Ramon y Cajal's work made clear that the neuronal theory was correct. Nervous tissue was not simply a continuous net of fibers. Rather, it is made up of individual cells. Each one of the cells in nervous tissue, the neurons, consists of a cell body and long fibrous processes which extend away from the cell body, the axon and dendrites. Ramon y Cajal noted that the fibrous processes from one cell appear to make contact with other cells, suggesting a means of transmission of information, and that the entire cell could function as a conductive device.
So I'm going to leave it there. She kind of glossed over, she talked about the conflict between Golgi and Cajal, but I'm going to post this paper for you. Let's see here. Okay, sorry. Oh, hold on. Here it is. Okay, so this is a historical reflection of the contributions of Cajal and Golgi to the foundations of neuroscience. I'll post this for you, but it really details what happened at the ceremony for the Nobel Prize. Golgi and Cajal were both awarded the particular Nobel Prize that year. It was a joint award, and because they were in conflict with each other, the award ceremony, when they received it, and their presentations, Golgi got up first, and then Cajal. You can see he was kind of a hothead, right? Even as a child, he was kicked out of a lot of schools. So he got up and really told the audience his displeasure at being number one, given the award with Golgi, and then just blasted Golgi on basically his ideas. So it was quite the contentious presentation in 1906, which is interesting. But I will post that. This paper actually kind of details their conflict and Cajal in general. So Cajal obviously is right with his neuronal theory. Golgi was not right, thinking about the nervous system as a nerve net, the reticulum theory. Okay, so pretty interesting. Little spice it up a little bit this morning, talking about nerves and the nervous system, but back then they weren't sure. Obviously in the 1950s with the electron microscope, they basically proved without a doubt that Cajal's theory was correct. Okay, so let's talk more about neurons. Like I said, those aren't the most abundant cells